All right, my friends, feel free, and it's totally up to you, but you could always start by, if in doubt, expand it out type steps. So for this one, you'd have 5/7 plus 5/7 squared plus 5/7 cubed, and so on. So ask yourself, does this look geometric? And the answer is yes. Next question, does it look infinite? Yes. Last question, what's my common ratio? The answer would be 1/7. And is it between -1 and 1? The answer is yes. If you can say yes to those three things, then feel free to use the formula first term over 1 minus the common ratio, and then simplify as you go. So you'd have 5/7 divided by 6/7, flip and multiply it, you should get 5/6. And that was the answer for part A. Okay. Part B, geometric, check. Infinite, check. Common ratio between -1 and 1, it's -1/4, and so yes, check. So for this one, what would your first term have been? It would have been 3, because since you're starting at 0, would have been 3, and then over 1 minus your common ratio. And so your answer would have been 3 over, would that be 5/4, I think? Flip and multiply, you'd get 12/5, also known as 2 and 2/5. Either of the last two would be great. Okay, part C, this time geometric, yes. Infinite, yes. Common ratio between -1 and 1, wah, wah. No, the answer is that common ratio is 2. So you should not, I repeat, not use this formula right here. It will make your math sad.
Guess what?
What, sweetie?
My ball. I'm gonna take this to the beach in my suitcase.
Oh, okay. Yeah, okay. All right, my friends. So instead, fall back and if in doubt, expand it out. So, and just kind of use your best logic to think it out. So like if n is 1, you would have gotten 2/10. If n is 2, you would have gotten 2 squared over 10. If n is 3, 2 cubed over 10, etc. So I hope it makes sense that the terms themselves are getting larger and larger in magnitude, and you're adding up infinitely many of them. So the answer for part C would have been that your terms add up to infinity. There we go. All right, my friends. Last example, example 2, is going to check and see if you understand this material so well that you can kind of like use it backwards. So the directions are to write each repeating decimal as a fraction of 2 integers. And I know there are other tricks for how to do these, but I'm going to demonstrate how to do these kind of using the sum formula for a geometric series backwards. So for part A, we're going to take 0.12121212 repeating and see if we can use this formula backwards to get that. So I think for part A, I'll go ahead and just demonstrate. If you already know how to do it or think you have an idea, feel free to pause the video so I don't steal your thunder. But I'll go ahead and demonstrate it for part A, and then there will be a part B and a part C where you can also practice and make sure you got it down, okay? So the first thing you'd want to do is show that this decimal could be written as an infinite sum. So, and the way you break it up is you break it up like by repeating pieces. So you'd write it like this. This is the same as 0.12 plus, and then, so that would get you out this far. And then what would I have to add to get you out this far? Yep, 0.0012, and then what would I have to add to get you out that far? And then as long as you show the first 3 terms, you're probably fine. It typically takes 3 terms to establish a pattern. So I'll just show the first 3. So this is, so I'm showing first of all that this is an infinite geometric series. Why do I say it's geometric? Because what would you have to multiply 0.12 by to get 0.0012? Well, you moved the decimal to the left 2 places, so you would have multiplied by 1/100th. And then notice that you could multiply your second term by 1/100th again to get that third term. So this is geometric. It's infinite, and its common ratio is 1/100th, which is between -1 and 1. So since that's the case, you can use this formula over here to say what it would add up to. So it would equal the first term, which is the 0.12 you see there at on the first term, and then over 1 minus the common ratio, which we've already established is 1/100th. And then simplify it. You could turn it all into decimals or all into fractions. I kind of prefer fractions. So you've got 12 100ths on the top. And then 1 minus 1 100th would be 99 100ths. And then a quick flip and multiply. The 100ths would cancel out, and you'd be left with 12 over 99. And then before we quit, we're going to keep it classy by reducing our fraction. 12 and 99, both divisible by 3, so we'd be left with 4 divided by 33. There we go. So if you don't believe me, then grab your calculator and do 4 divided by 33, and you'll see that it is 0.12 repeating. There we go. All right, let's see how you do with part B. Now notice part B has a piece that doesn't belong, which adds a little bit of challenge to it, but see if you can figure it out and then check in with me in the next video. Good luck.